tell you any of them. I have no interest in telling you any derivative rules. I'm interested in your coming up with them. Good stuff. Because the last unit that we studied, that was the FF prime, F double prime relationships. Remember, I used to ask you questions like, the original function is increasing. What does this mean about F prime?
Positive.
If the original function f is increasing, then F prime, David, what do you know about F prime? F prime is positive. What if F has a point of inflection? F has a point of inflection. What do we know? What do we know? What do we know? One person, two people, three, four? What do you know?
F prime changes from increasing to decreasing or decreasing to increasing.
F prime changes from increasing to decreasing or decreasing to increasing. Can you guys show me a cuss point? Cuss point. It's been a while. Cuss point. Cuss point. Cuss point. Right. Cuss point looks kind of like this. It's the pointy kind. If F has a cuss point, F prime
Does not exist.
does not exist at that point. Thank you for making me a better teacher. Like all those things are what we're going to use to come up with these new derivative rules. So let's look at this graph of f of x. This is a graph of f of x equals natural log of x, a parent function that you know, you've known it for a long time. What I want you to do is have a quick conversation with somebody near you. What are the things that you know about this graph that help you understand what the derivative is? So you're going to look at the graph of f. What are the things that you can use to describe f of x that tell you about f prime? 1 minute. Go for it. We're filming, right? Okay, good. And don't use the word it. Hold him to high expectations, Giselle. He needs it. We're fighting. That's preaching.
I'm not preaching. I never preach philosophy. I'm
At
just
x
saying
equals
that.
1, it changes from negative
What are the things about f that tell you about f prime?
So that means it's fine.
Increasing, so all of it is increasing, so all of that prime is going to be positive. Yeah, that prime would be all positive.
All right, let's get some hands. Something that you know about f and what it tells you about f prime. I'll take anything from anybody. Edgar, get me started.
Since all of f of x is increasing, that means that all of f prime will be positive.
Okay, f of x, I'm going to write it this way. F of x is increasing where?
Everywhere.
Everywhere. I disagree. I disagree. That's a really strong statement. You and I are really strong men in mathematics. But Abraham, I cannot agree. F of x is increasing always? 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 Always?
Oh, from 0 to infinity.
Is increasing, I'm just going to write for x greater than 0. We have domain restrictions with natural log, right? Can't take natural log a negative number. So if f is increasing, Abraham, what do you know about f prime? F prime is positive for all values of x greater than 0. Great, that's one thing. What else? Let's get some new hands on this. F is increasing for x greater than 0. F prime is positive. What else? What else do we know? Oh, so sad. So sad. Adriana, what else do you know? F has a vertical asymptote at where? At x equals 0, right? I've got that vertical asymptote over here at x equals 0. That tells me something about f prime. F has a vertical asymptote. Maybe you need to pull out that gold sheet. David, what do you know?
F prime has a vertical asymptote.
F prime has a vertical asymptote at x equals 0, right? We talked about that before. If your function has a vertical asymptote, that vertical asymptote stays with you forever. Other things. Other things. Rambir, what else?
F of x crosses from negative to positive at x equals 1.
It is true. F of x crosses from being negative to being positive at x equals 1. What would that tell you about f prime?
A minimum. Oh no, that's backwards.
Right, that's the antiderivative. Anthony, you guys were having a conversation about concavity, right? Tell me about the concavity. F is concave down for x greater than 0. So what does it tell you about f prime, Anthony? F prime is decreasing. Ooh, animal noises. Okay? So f is concave down, f prime is decreasing. Something else that I don't know that we actually have vocabulary for yet. As x approaches infinity, what happens to that graph?
The slope decrease.
The slope is,
Getting closer and closer.
it's kind of flattening out, right? The slope is decreasing. We're getting less positive. So as x approaches infinity, the slope becomes less positive. Less positive. So as x approaches infinity, what's f prime doing? My slope is getting less and less and less positive. So the derivative, it should be approaching 0. Now there might be other things, but I bet you guys have a pretty good idea what f prime looks like. If f prime is positive for all values of x greater than 0, decreasing for all values of x greater than 0, has a vertical asymptote and gets closer to 0 as x approaches infinity, give me a quick sketch. What does f prime have to look like? What would that have to look like? Hold all those things together in a one graph. Always positive, always decreasing, vertical asymptote, getting closer to 0 as x approaches infinity. Okay, what I'm seeing on most papers looks like that. Everybody okay with that? Anybody recognize that? Like you see that and you start thinking parent functions? Noemi, what do you see?
It's the log, the parent function.
Well, this is the parent function for natural log of x.
It's the which the other one with the e.
Okay, there is something with the e, but we got to get it right. We got to get it right. Christian, what do you think?
To the negative x.
E to the power of negative x kind of has this behavior. That is one of the parent functions that you know. There are others. David.
The right side of 1 over x squared.
Oh my God, I could not have said it better. It's like you've been hanging out with mathematicians. The right side of 1 over x squared does that. There's at least one more. There's at least one more parent function. There's a reason I push for parent functions all the time. Eunice, what's the other one?
1 over.
Okay, 1 over x. But you guys all agree that like all three of those parent functions have this kind of behavior? This looks familiar? Now I will tell you that the derivative of the natural log of x is one of these three. I will not tell you which one.
Not all three.
It's not going to be all three because all three are a little bit different. But a way to figure this out, let's go to the calculator. Okay, let's take out the calculator. And unfortunately, I have to go a little bit low tech here. My monitor doesn't seem to be working today. And then I'm just going to get out of your way and give you guys some practice with this. Oh, the good times we will have today. Martyr, can you turn the lights off? Or one of the lights off. People are already looking pretty rough. If you're sitting next to somebody who looks like they're falling asleep, you have my permission to pinch them. I can't do it because I need this job, but if you pinch somebody, what is that, a demerit?
Mr. Estelle,
Mr. Estelle
It might be a beast point.
abuses us.
He's not a good pincher, well that's
I'm
good.
holding them accountable.
Okay. Or you could just pinch yourself.
Give myself a beat.
Stop.
Is it on the thingy? Chokes people really
Okay.
good.
So here's what I want you to do. First, let's graph the natural log of x. So low tech. Gosh, I gotta do it myself. I miss the days of
This
Mark.
is so bootleg.
Hey, it was me.
Old school. I know, but YouTube, but it was him before it was you. So we've got natural log of x. I want you to get on the screen the graph of the derivative. Get on your screen the graph of the derivative. I want the whole graph. Marvin, do you remember how to get the graph to show up? What do you do?
we go to the button besides the book.
The button besides the book. I agree.
Press that one.
And then we're going to press this guy. But you need to be really careful, and I've been watching some of you guys in your calculator skills, and we're forgetting. If you're trying to graph the derivative, you have to start with a function, right? You're graphing a new function, then hit the button. And then what goes in the bottom box? X. What goes in the next box? It's going to be f1 or whatever your function is, like f1 of x. Give me a quick thumbs up if your graph looks like that. The blue graph, the original function, the red graph, the derivative. But here's the thing. Your calculator doesn't actually know the equation. It doesn't. It doesn't know the equation. It knows what the graph looks like. So what are you going to do to figure it out?
Ask it nicely.
Graph the other ones. Okay, so like go through. Let's do like another tab. So like F3. Let me try e to the negative x. E to the negative x. Did that match?
No.
No, it can't be e to the negative x. Daisy, do you see why it doesn't match? You're not sure? Okay. The blue graph is the original. The red graph is the derivative. The black graph is e to the negative x. Do you see why it doesn't match? Why doesn't it match?
Because it's not, because the red one shows the graphical derivative.
The red is the graph of the actual derivative. The black is our guess. If I was right, I wouldn't see the red anymore. So not e to the negative x, what is it really?
1/x.
Is it 1 over x? Or as somebody said earlier, it's the right-hand side of the graph of 1 over x because of the domain restriction. We're not looking at this guy here.
That's what I got.
Okay, so guess what? New derivative rule. Derivative of the natural log of x is 1 over x. Now, this is not a proof. You didn't prove anything. Don't go to all your high-powered universities next year and say, oh yeah, we proved it, like I grabbed it on my calculator, and look at, this is the derivative. No, this is some graphical evidence. Over the course of the next 10 minutes, I want you guys to figure these out, and you've got it in your hand out there. I want you to figure out the derivative of the sine of x, the derivative of the cosine of x, the derivative of e to the x, and the derivative of e to the negative x. If all goes well, you will uncover the derivatives for all 4 of those, going through a similar process.
I have a question.
Yeah.
How is that the derivative of 1 over x is 1 over x, so that's like all the derivatives?
We'll talk about that in a little bit. Okay, 10 minutes, you're working through the graphs on pages 3 and 4.
Y'all wanna watch us? Say hola.
I mean the derivative. The red one was the derivative. You can see the derivative more because the 1 over x covered it. Okay, look for the derivative.
Oh, okay, yeah, okay. That makes sense. I was confused. Okay.
Now we
Okay.
know.
So it's really derivative for x greater than 0. Because the natural log function is only defined with positive x values.
Okay.
Right.
That's
There's
right.
no graph.
Oh, it's. Oh, it has boundary. I thought it was supposed to be like oh, that's cool. How much does it cost?
$20.
See, there's people like you that are.
I didn't buy it.
Oh. I was gonna say people like you are like supporting.
Were we supposed to keep that graph on or no?
No, we're not. We moved on. We're can you please move on?
My name's Amir.
What did you call her?
Wait, what?
Amir? You called her Amira?
No, I just said you had to move on. We moved on.
You said Amira.
Call me Amir.
I called you a mirror?
Amir, whatever. I don't know what you call me.
Just
Yes, it does. I don't call you Josua.
Oh my god.
Oh my god. You guys hear what he makes us listen to?
Who is singing that? Is that the mermaid? Is that the mermaid? Obviously, I don't belong here.
I want to learn this. I'm performing at the talent show.
Who is saying that? It sounds like somebody from a Disney character.
Yeah, what do we do?
Well,
Oh my god.
same thing we did before.
Yeah, I already grabbed them.
And then think of graphs that would do this. Actually, I don't even know. He was talking about some pairing functions. I didn't even come up with them. That was insane. So I can help you.
So, graph. Not great. Okay. No one's going to buy your graph. But, how does it decide the graph?
Yeah, what are we doing? We're trying to find out what this is.
This graph has a horizontal tangent line, this graph over here.
Why are you guys doing this? Are you guys cooking this? Is that a video?
It's a dancing game.
All, like, what I like
nice.
about
In the corner
this
of the globe,
activity,
like-
this opportunity, is you get to go back to all the old skills.
Alright.
I just grabbed it.
But
Yeah, but I don't
this
know.
looks like it's the graph of cosines, but just because it looks like cosine doesn't mean it actually is. I want to make sure that your graph
I messed it up.
is okay.
Ah.
How are we doing?
No, I got that far.
Okay, so, but did you sketch it by hand?
No,
I want you to get the practice with sketching it by hand.
Sketching it by hand.
Sketch it by hand first.
Okay, and then we're gonna calculate it.
Just like we did with the natural log. We started with the graph. What does it tell me about the derivative? Once you've got the sketch in front of you, then you're probably going to have a good idea what the derivative is.
But that's just my guess.
No. That's the same thing, so you wouldn't be confused. But we do have the same thing.
Just like we did with the natural log, that's where the work. And that'll avoid making these.
Oh, we were not supposed to use a calculator to sketch it. That's what but then he meant like, copy this here.
So like, since the derivative of this is this, wouldn't this just be that? Wouldn't this be the derivative of that?
I think they are derivatives of each other.
Yeah, that's what I mean.
So if that function has horizontal tangent lines, the derivative is. So you have
Nearly there. How do people do that? They like shake their voices up and down.
this function probably
I cannot do that.
Because you can't see it.
Can you do that?
No, because I can't
Because
see
you can't
it.
see.
Exactly.
Whoa, relax. Sometimes you get angry so
Dude, I don't not get angry.
You get frustrated.
I never get frustrated. I'm the most frustrated. No, I will not frustrated.
You're getting frustrated.
I don't get frustrated.
Yes, it is.
What is frustrated? Define the word frustrated.
Frustration, the feeling of frustration. I'm pretty sure it says that.
I know, but okay, I just want to. You know what I mean?
See?
What I mean is, frustration could mean different things for me. Dude, my mom brought glow in the dark nail paint or whatever. I was gonna put it all into my pink shit.
I love when you guys think they're cute.
Yeah, but then I was like, that's
Oh, we are supposed to do that, aren't we?
What?
Don't say that.
Don't say that.
why. It's
It's flamboyant. It's not even. It's just nail polish.
not just the orange, it's yellow. You can actually see it, like it's yellow color, but it goes in the dark. If it was clear, I would have worn it, but it's not clear.
Okay, then you're not gonna have cold blonde dark nails.
Duh.
No, but I get to live knowing that I have access to cool clothing.
What about you don't? Because you don't want to.
Oh my love. Oh my god.
I don't want to use it at school. That's cool. You use it at school. I use it.
Increasing.
You're starting with the origins, and then you're increasing, then you're decreasing, but not only increasing, they're functions start with the origin, and then they're decreasing and increasing.
I don't know what I'm doing.
part of why I put this activity together this way was so that you can.
Is that what we're supposed to do in labeling and stuff? How we do?
So what have we figured out with our derivatives?
This is called.
They are derivatives of each other.
I don't completely agree with you.
Wait, what?
When we do cosine.
Yeah, the derivative of cosine is not correct.
That's fun.
So the derivative of sine is not cos.
No, that's the one that you are right about.
Oh, okay. And derivative of cos is different from derivative. It's not sine.
It's not the sine of x. It is close and it is related, but it is not sine of x. And if I look at Jasmine's paper here, Giselle's paper here, I'm so sorry. Don't know why.
Oh, that's so disrespectful.
Right, I see that her graph passes through the origin. That's a good thing. But then your graph decreases then increases. That's not what the sine of x does.
This one?
No. This guy over here passes through the origin.
Oh,
Then the
it's
graph
upside
decreases
down.
and then so if it's upside down,
The inverse of cos.
not the inverse.
No, not the inverse.
Not the inverse.
1 over cos.
It's, I know what it is.
What is it? Cos is negative 1. That's so off.
All it is it's a reflection.
Yeah, it's a reflection.
How do you reflect something over the x-axis?
Give it a negative.
Oh, that.
It's the negative of the sine of x.
Negative. So, I know that.
This is fun.
No, it's not,
is
Mara.
so
If this
much
was
fun.
fun, you would have been more awake. Let's be honest, you're lying to yourself now.
What did you get for the verses? Is it still negative cosine?
No, that's just close. That's just close because that's close, and those two are exactly the same.
Oh, right.
Negative sin.
Dude, what is the point? I've seen some people that have their watches on and they don't have numbers. And how are you supposed to read a watch that doesn't have numbers? Like, you have to take your time to like count one.
Just eyeball it. You should know where the.
One more minute.
Yes.
I got so many answers to that. I got one here, one here, one here, and I got one on my left.
If I'm right,
I was climbing a tree that has spiders on it. Yeah, I should not have climbed a tree. I think we should move on, guys. We're done with this page.
I've been up since 3:45. I cannot function.
What is nuff? Do you guys know what nuff is?
I'm bleeding.
Are you serious? Oh, you have such gentle skin, bro.
I didn't either.
How do you get cut by a simple marker? Wow, dude, you must be ashamed of yourself. That's so sad. Now, how do you live being that dedicated? I cannot.
All right, so let's get these 5 new derivative rules committed here. Now I realize some of you made it through all 4 of them. Fabulous. Some of you made it through 2 or 3. That's okay. Derivative of sine of x. Everybody, what is it? Oh my gosh, so awkward. 20 teenagers in the room, and it sounds like mice. Derivative of sine of x is?
Cosine of x.
Not cos, but cosine of x. The derivative of the sine of x is cosine of x. Derivative of sine of x is cosine of x. Derivative of cosine of x
Negative sine of
is negative sine of x. The derivative of e to the x is e to the x. Or if you ask Juan Cuso last period, sorcery. The fact that the derivative of e to the x is exactly itself was apparently not something that fit comfortably in his world. David also agreed. He's like, we must be doing something wrong, team. There's no way the derivative of e to the x is e to the x. It is. We're not proving any of these things. So strange. Okay. And the derivative of e to the negative x, did anybody figure it out?
I thought it was a natural log.
Negative e to the negative x.
The derivative of e to the negative x is, I'm going to write it this way, e to the negative x times negative 1, which is the exact same thing as negative e to the negative x. We've got 5 brand new derivative rules. Without looking, what's the derivative of sine of x?
Cosine of x.
Don't just say cosine, cosine of x. Derivative of e to the x?
E to the
E to the x. Derivative of natural log of x?
1 over x.
Yes, that was 11 minutes ago. Without looking, the derivative of natural log of x is 1 over x.
The right
Good.
side of x equals
The right side of 1 over x. Thank you, Ramir, for making me a better teacher. Derivative of cosine of x? Negative sine of x. Derivative of e to the negative x? Negative e to the negative x. Derivative of natural log of x?
1 over x. Right side.
Okay, derivative of sine of pi?
2 pi sine. 2 cos.
Negative
2 cosine. That's it.
Derivative of sine of pi?
Negative cosine pi minus.
Oh, cosine phi.
Cosine of pi?
Oh, damn it.
Not right. Derivative of sine of pi?
I was thinking negative pi.
Anybody know anything about pi?
Oh, it's a constant.
Pi is a constant. So sine of pi
Zero.
is a constant, and the derivative of a constant is still 0. We'll play back the first. All right, good. So we've got the basic derivative rules right. Now we've got 15 minutes left. Oh, so excited. 15 minutes left to push your thinking a little bit more. I love to push the brains. We're going to get through some of these, not all of these, and that's okay. Rambir, before you take my crew, let's make sure that we talk. All right, so problem number 2. Adriana, can you read problem number 2? Using your best math vocabulary.
If h of x equals sine of x
Times! Yep, keep going.
times e to the x,
Times, yep.
find h prime of x
Yep.
and h double prime of x.
Oh my god, I love it. So, I want to find the derivative of sine of x times e to the x. And we've got these 5 derivative rules, and you know what happened last period? They were like, we have these 5 derivative rules. These are the new 5. These are the only 5.
Time.
Derivative of sine of x times e to the x. What are we going to do?
product.
What are we going to do?
Product rule.
Product rule. It must be product rule. Okay, 30 seconds. Finish it off. Finish it off.
Sine of x.
H prime. Let's see. Sine of x times e to the x. Product rule says take the derivative of the first, leave the second alone. Derivative of the first is cosine of x times e to the x plus leave the sine of x alone times the derivative of the second one is e to the x. Cosine of x times e to the x plus sine of x times e to the x. How many guys just got that one right?
What if I just put the little prime thing on?
Okay, if you got that right, go for h double prime. Go for h double prime. If you didn't get it right, now's a great time to ask me any and all questions. Edgar.
So we can't just say the sine prime of x. It has to be cosine.
You have to actually finish off the derivative. I need you to know that the derivative of sine of x is cosine of x. Now, all my folks that are in the process of finding h double prime, you need to find the derivative of cosine of x times e to the x plus sine of x times e to the x. Derivative rules that I need here. Product rule. Sum rule. And product rule again. 2 product rules. 2. Isn't it exciting? Okay, so this first one, derivative of cosine of x is negative sine of x times e to the x plus cosine of x times e to the x plus derivative over here, cosine of x times e to the x plus sine of x times e to the x. If all goes well, you have 4 terms at the end. How many guys honestly came up with h double prime? I care a lot about h prime right now. H double prime, I'm kind of going for extra innings. If you really want to show off for the ladies, you might notice this negative sine of x times e to the x. And there's a positive sine of x times e to the x all the way over there at the end. So guess what? Cancel those out. You want to impress everybody in the room? You might even see this cosine of x times e to the x and another cosine of x times e to the x. And you're really going to tell me that there are 2 of these cosine of x times e to the x's. That's how I'm going to hide it from you on the multiple choice part of the test, but you could leave the unsimplified version on the free response.
Oh, I did it wrong.
We're good? All right. Number 3. Let's go for number 3.
That's the final answer for the H.
That would be the final answer for H double prime. Daisy, using your best vocabulary possible, can you read number 3 for me?
For g of x equals natural log of,
Wait, one more time?
for g of x equals natural log of sine.
Of! Yes! Of sine of x, natural log of sine of x. Minus, keep going.
Sine of
Of! Sine of e to the x plus,
says e of
not e of,
e sine of x.
not e sine of x, e to the power of sine of x. I wanted to emphasize that word of because whenever you see of, it does not mean multiply. I'm so glad you're thinking out loud. So wrong. It doesn't mean multiply, it means chain rule. It means composition. There's, right, like a lot of kids will they'll put it in like parentheses, right? There's that implied parentheses. Oh, so how am I going to find the derivative? Natural log of sine of x. I heard chain rule. Chain rule, not power rule. Chain.
Mama.
Derivative of the mama. What's the derivative of natural log of stuff?
1 over it.
It's going to be 1 over stuff. Right? It's 1 over the stuff.
Oh, yeah.
Don't stop. The derivative of natural log of stuff is 1 over stuff. We're using the chain rule.
So
1 over the baby times baby prime. Baby prime?
cosine.
Cosine of x. Minus sine of e to the x. Chain rule again. Sine of e to the x.
Minus cosine.
So derivative of the mama is cosine, leave her baby, times derivative of the baby. Derivative of e to the x?
E to the
E to the x. Sorcery, yes. Plus e to the power of stuff. Derivative of e to the power of stuff
E to the
is e to that same stuff times derivative of stuff.
Oh.
Not 0.
Oh, cosine. Sorry.
Cosine.
Would you bring the cosine down as a whole number, or try to make it into like a
I would leave it. I would just leave it. Okay? So we've got like secret multiplications that are happening. We also sometimes have secret chain rules that are happening. Enjoy number 4. Enjoy number 4. It was created just for you all and your smarticle particles. Enjoy the ride.
No me espantas.
Have a strategy conversation. And Rambir, you need to get going, right? And you're taking Giselle. Why don't you guys come on over and I'll tell you what the homework is. You need to have a strategy conversation.
Sine over cosine.
Keep going. Okay, so for Rambir and Giselle, the homework is on the back, problems 1, 3, and 4, and then choose 6. Not problem number 6. Choose 6 problems.
out of 6 through
Out of 6 through 17. Huh? Okay. Oh my gosh, Jonathan is on the road to brilliance. So is Anthony.
There's 10 is sine over cosine.
What do you
God, I am such a pusher, such a pusher. Tangent of x. How on earth are we going to find the derivative of tangent of x, Abraham? What are you going to do? Wait, Edgar? Abraham? What is tangent? I'm sorry, sine over cosine, that means nothing to me. Sine of x over cosine of x. Why is that helpful? What are you going to do? If tangent of x is sine of x over cosine of x, David, what are you going to do?
You just find the derivatives of both sine of x and cos of x, and then that will give you the derivative.
But I'm afraid that what you're telling me is that the derivative of sine of x is cosine, and the derivative of cosine of x is negative sine of x, and you're going to write it that way. And we would never do that.
Oh no.
We would never, ever do that. Daisy, why would you never, ever do that? How are you going to take the derivative of sine of x over cosine of x?
I was going to say you have to use the quotient rule.
I was going to say that you're 100% right. You need the quotient rule. And even with that, we're not done. Not done. Oh, love it. Okay, so the quotient rule, little low d high minus some high d low, low, low. Now, Jonathan, what would make your answer even better would be labeling the function. I mean, I wrote your letter of recommendation. It would be nice. Okay, so quotient rule, low cosine of x times d high. How do we do that? So low d high minus high d low. So that's sine of x times negative sine of x all over cosine of x, the whole thing squared. How many of you guys honestly came up with that for my derivative rule, people? Nice. That's great free response answer, not the multiple choice answer. I'm going to hide it from you. How am I going to hide it? How am I going to hide this? What am I going to do? I mean, Jonathan, what am I going to do? You're going to combine, not really the phrase I was hoping you were going to say. There are no like terms here. Jennifer, what do you say?
Because you're multiplying cosine of x times cosine of x, so you're just going to say cosine squared.
Okay, cosine of x times cosine of x is the same thing as saying cosine squared. When I write the square just after the cos, that means that's the same as cosine of x, the whole thing squared. So that's this part. Minus sine of x times negative sine of x.
Minus sine.
Minus sine of x times negative sine of x. Not negative 2 sine.
Negative sine squared of x.
I agree that there's a sine squared. I agree that it's a negative sine squared. But we are subtracting that negative sine squared of x, so
Plus.
sine squared of x over cosine squared of x. That's really good. I'm going to hide it even more.
Oh, Dios mío.
Because I have those high expectations for you all. There's something that someone in the room knows. I can feel it. Somebody knows it. Jose, what do you know? Cosine squared of x plus sine squared of x is equal to 1. This guy here, it's that sneaky Pythagorean identity.
I hated those.
Too bad, didn't ask. Okay, that's the Pythagorean identity. So that means that this derivative, oh my god, it's really 1 over cosine squared of x. But you know, I am so sneaky, Jasmine, I'm gonna hide it even more. There's one more thing. If I'm going like full maverick, full big brain, David?
That's a mess.
Oh, grit. Oh. 1 over cosine. If it wasn't for the square, 1 over cosine, what trig function? What trig function?
Sine of x squared minus 1.
Ah! 1 over cosine is secant of x. So 1 over cosine squared is secant squared. So secant squared of x is how I'm going to hide this. So guess what? For those of you that your brain hasn't totally leaked the brain fluid, hold on. If you have the capacity to memorize I would memorize this one. I would add it onto the list.
Memorize
The derivative of tangent of x is
Secant squared of x.
secant squared of x. Or, the next time you come across tangent of x on the streets and you need to go find the derivative, do your quotient rule in 14 trig identities. Or just know that the derivative of tangent is secant squared. Tonight's homework is this. I want you to do problems